examinations, whenever you are going to prepare for the examinations, make it sure these three topics you prepare well. So the major topics left over are hydrogen production and storage. That was the one topic. Nothing but a question may be appearing from hydrogen productions as well as hydrogen storage. Two questions. And one more question is regarding the fuel cells. And last one is the hybrid energies. So these are the three topics, but most of the times you are going to have the questions either from the tidal or wave or ocean, geothermal. So I'll repeat the questions here. So majorly, what questions you need to concentrate in this particular unit. The questions may be of the tidal energies, the second one wave energies, nothing but tidal energy. If I'm considering, we are going to have the questions of single basin and double basin, how it works, what is tide and how it works. Wave energy part, you are going to have only one single question, how we are going to produce the energy from the wave floats. That was the question. The third one, ocean, you are going to have. Fourth one is geothermal. That was also going to be one of the important question. And after that, we are going to have the hydrogen production and storage. Hydrogen production, one question, hydrogen storage, one questions, and fuel cells. So these three questions, most of the 90% of the times, uh, among these three, hydrogen production or hydrogen storage or fuel cells, any one of the question will always appear in most of the question papers, right? Let us see that why this hydrogen is going to be that much important. Now, up to this, whatever we have discussed regarding the conventional fuels, maybe we started discussing with the conventional fuels, just like your petrol, diesel, kerosene, or coal, all these things. That was comes under the conventional fuels categories. But whenever we are going to have burned the conventional fuels, we were having it certain amount of emissions always. Maybe these emissions will be of carbon monoxide, carbon dioxide, HSE emissions, and NOx emissions. And each and every emissions, whatever it is emitting, is always going to have it certain amount of negativeness, certain amount of problems. So that was the things, always it was there. For each and every emissions, whatever it is producing is consisting of certain problems. Now, because of that particular reason only, as the complete environment is completely filling with the emissions, we are going for non-conventional things. And later part we have discussed about the solar, wind part, biomass, biogas, and now we are going to come for this particular type of energies. But when we are considering one point where you can find this hydrogen content, if you are going to use this hydrogen content in your normal vehicles, just like with the help of a battery operations. So this, if you are using these hydrogen fuels in place of your petrol, you are going to have it a separate type of emissions. Just like you can take an example here. Say if you are riding a bike or if you are riding a car, you are going to have, when you are riding your bike or car, you are going to have the smoke from your exhaust pipe. Now, normally this smoke, whatever it is coming, is going to say that certain amount of pollutions. Of course, whatever we have discussed regarding CO emissions, CO2 emissions, NOx, HC, all these things it is going to consisting. Now, important question, when you are using the hydrogen as a fuel in place of the petrol for your car or for your buses or any automobiles, you are going to say that the emissions from your exhaust pipe, you are going to have the water now. You are going to have the water. So when we are going to have the water content, we can consider that this is not going to be having any emissions at all. This water content is straight away, it goes out and forms like a vapor in the environment, and it doesn't have any problem at all. So that's why we always says that this hydrogen fuel is going to call as a zero emission fuels, because it won't create any COs, it won't create CO2s, it won't create NOx emissions, or it won't create HC emissions, which are going to cause a specific problems for the human beings. That's why we call this as a hydrogen emission, hydrogen fuel is called zero emission fuels. That's why majority of the nowadays technologies they are moving towards the hydrogen part. Not only in the buses, not only in the cars. Now this is going to be used in the aircrafts. This is going to be moved in the aircrafts also. Now, very simple things what we can consider. How we are going to get it now. When I'm talking about emissions, I told that water is going to come in place of the emissions. Very simple. Suppose if you want to burn a petrol in your car or in your bike, how we are going to do it? So if you are observing it carefully for your bikes, if I'm taking for your bikes, you always see. So you are going to have at the bottom of your bike, you are going to find a specific pipe will be there, which is going to hang. If you're not observed it, please observe it. Now what it does, this is going to suck the air which is needed for the combustion of petrol. Maybe the petrol we are going to send it from your tank to the engine. Now for burning of your petrol, it always needs oxygen content. Now this oxygen content is going to be absorbed, or it is going to be sucked through that particular pipe. Nothing but it is confirmed that wherever, whatever may be the fuel, if you want to burn it, it needs oxygen content. Similarly, this hydrogen also, whenever it needs to burn it, it needs oxygen content. Now, whenever you want to burn the hydrogen content in your car, you need to supply oxygen content. When we are burning it, hydrogen H2 and oxygen content O2, it is going to convert it into H2O along with a certain amount of energies. This H2O, whatever we call this as a water, is going to be an emissions, and it is going to come out of my exhaust pipe. Just like whatever you are going to get it like a smoke. Now, during these particular things, it is a, what you call exothermic reactions. What you can consider, more amount of heat is going to come out, and this can be used for your running of your car, bike, or something else. This is a working phenomena of how hydrogen is going to be used for running of your automobiles. Now when you are observing it, it doesn't have any maintenance at all. It's a very simple. It doesn't. I'm not going to use it any car, any fuel content now. Just like your bike, if you are observing it, each and every 6 months you need to change your lubricating oils. You need to change something else. So differently, that is nothing but certain amount of maintenance is always be there. But whereas for this, the maintenance is going to be very easy because it doesn't find any type of moving components here. Any type of moving components. So it's only reactions here. So that's why this hydrogen fuel is going to have less amount of maintenance here, and more amount of applications are also there. Now let me go for saying how we are going to produce the hydrogen content here. Especially for producing of the hydrogen content, it needs artificial methods. It needs an artificial methods because in a natural air, whatever we are going to observe, the amount of hydrogen that is present is going to be very, very minute. If you are considering it, 79% of oxygen content will be there in the air, whatever we are going to inhale it. This air consisting of 79% of that, and the remaining things a little bit, little amount of the remaining things. Among all these things, hydrogen is going to be very little. When I'm saying that this little amount of hydrogen, whatever it is consisting in the air, extracting of this hydrogen itself is going to be too much cost. That's why natural separation of the hydrogen from the air is not going to be followed at all. They are not going to follow it. The basic reason here is whenever they are going to use it, they are going to have lot amount of money they need to incur it inside that. That is going to be the big problem. Now what we'll do here, instead of that, whenever we need to run it, our vehicles, you always needs to produce lot amount of hydrogen content. That's why we need to produce in artificially place instead of natural extraction or natural separations. We normally concentrate more on these particular artificial preparations here. That's why we'll say that hydrogen is going to be prepared artificially in different methods. You can find 4 to 5 different methods over there. But among all these things, we are going to discuss 2 different methods, which is going to say that which is going to have it more prominent methods is these two. Maybe we have lot number, but these 2 things we are going to discuss because many applications, many companies, they are going to produce the hydrogen by these 2 methods, right? See here how this is going to be formed. This is an electrolysis process, very simple electrolysis process. If you are observing it the complete picture carefully, I'm going to find the first one is the total case, working case, just like your battery case. What you can consider, take an example of a battery case, inverter battery, whatever you call it. You are going to have the same thing, battery case will be there. Inside that you are going to have it electrodes. One, naturally, when I'm talking about electrode point of view, I'm going to have it 2 type of electrodes. One is a positive electrode, one is a negative electrode. What we call that as a cathode is nothing but a positive electrodes. Anode, what you call negative electrodes. Sorry, reverse way. Uh, Anode is going to be a positive one, cathode is going to be a negative one. So this way you are going to have it that differentiation, 2 electrodes. But now, whenever I'm saying that these 2 electrodes should be immersed, it is going to be immersed in a separate electrolyte. What do you call electrolyte? Now, what we'll do, this electrolyte, they are going to use it in a general phenomena in our normal in normal inverter batteries. Also, we are going to use it H2SO4. Here also we are going to use it electrolyte here. And now in between these 2 things, I'm going to have it a membrane. What I call membrane, which is going to just like acts like a filter. What you can find filter, which allows which allows to flow in only one direction, not in the reverse directions. That is the major beauty of these membranes. Remember, this is going to consisting of 2 electrodes, cathode and anode electrodes, and these 2 things are immersed in electrolyte, and now these 2 things are separated by a membrane. The major function of the membrane is to allow the ions to flow in one directions, not in the second directions. It won't allow in the second direction space, one way, right? And now these 2 things, what we can consider cathode and anode, both the things are going to be connected with the outside or external circuit. What I can consider external circuit. You can observe in the figure yellow color lines. It's connected with an external circuit. But of course, in between the external circuit, you are going to have the applications. It may be application, maybe of a, a bulb, a fan, or something else, whatever it is. You are going to have it a specific application between this. But when I need to close the circuit. For closing of the circuit, you need to have it. So cathode and anode, both the things are like this. Now externally, this is connected with an applications. And now these 2 things, this side, 3 sides, it is closed. And now bottom side, it is to be closed with the help of the electrolyte, whatever you are going to use it. That's why if you are observing it carefully, in your inverters also, whenever you are not going to pour this particular electrolyte is over or evaporated, your inverter capacity is going to become less. And within the short amount of time, these electrolyte, these particular cathode and anodes, whatever we have, this is going to dry it and it is going to become overheated. If this electrolyte is there, it is going to be a good. Now coming to the picture, how it is going to operate here. See, first and foremost things, it started with the anode reactions first. At the anode point, so whatever the water content is presenting here. Now, naturally, as you people know that these things, particular things, it is going to consisting of water. Water is nothing but H2O. It is consisting of hydrogen as well as oxygen content both. Right? Now, at this particular anode part, we are going to separate these two things here. Now, when it is separated, just what you can consider two things it is going to form, like a H as well as O. If you are talking about this particular point here, you must see that how exactly cations will form, how exactly the anions is going to form. So when I'm talking about this, we need to go to the chemistry part, whatever we have studied in our intermediate. You need to see whenever you are going to have the hydrogen content is there. Now hydrogen is not going to be what you call inert one. It needs hydrogen is going to consisting of one electron. Now it needs two electrons for completing it or to become stable. In the similar process, if I'm considering the oxygen content, where the atomic number is going to be 8, but it's not stable. When it needs to become stable, it needs two additional electrons here. That's why you can say that two additional electrons it needs. But when it reacts with the hydrogen content, hydrogen is going to have it only one electron. Because of that particular reason, it reacts with the two hydrogens, H2O, what do you call covalent bonds. If you remember in our chemistry part, that's why oxygen will always react with the hydrogen content, two hydrogens, H2, because one hydrogen gives one electron, second hydrogen gives second electron. But oxygen needs two electrons here always. So H2O, that's why it goes. So it consisting of H plus ions, what it is going to give the electrons, oxygen, which is going to absorb the electrons. One may be the emitter, second one is going to be an absorber here. Oxygen is an absorber, hydrogen is going to be an emitter. Now, at this particular anode content, now it is becoming this hydrogen H2O is separating it now. It's going to be separated like H plus ions and O oxygen ions. And now this oxygen here, whatever we are going to have it, this oxygen content is going to liberate like a bubbles here because it forms oxygen. You know that it is going to be like a gaseous form. Whenever it is mixing with your liquid content, it comes out like a bubbles. Now that's why at the anode part, always you are going to find oxygen content is going to be liberated out. Now what is happening in the anode reactions? I'm going to have it two particular things. It is going to separate H plus ions and oxygen content is going to liberate. And of course, when I'm talking about H plus, always certain amount of electrons are also going to come out. Now, this is happening three. So at the anode part, I'm going to identifying three particular things, please. Oxygen is coming out. The second one, it is becoming H plus ions. When I'm talking plus, I need minus also to balance it. So when I'm talking 4H plus ions, it is coming. 4 electrons are also should come. When both the things are adding each, it is going to neutralize it. 4H and 4 electrons. Now these electrons, whatever it is coming out, is going to going out through the external circuit. Because as you know that if you are observing the figure carefully, so it is going to identify the yellow color line, so through which the electrons, what you call external circuit. Through the external circuit, electrons are going to move out. It's going to form. It's going to moving out of that. When it is moving out of that, what you call the applications, electrons are going to see, and when electrons are going to see, automatically you are going to have the current and everything is going to flow that way, right? Now when I'm talking about this particular things, now oxygen is liberated out, from at the anode part. Electrons, whatever it is formed, now it is also going through the external circuit. What remained here? The hydrogen plus H plus ions. Now this H plus ions is going to move towards the cathode part because it is attracted towards the negative, because cathode is called negative, and now it is going to attract it towards that. Now when it passes through that, it has to pass through the membrane. Just now I told you, membrane is going to allow this in only one direction, not in the reverse directions. It allows H plus ions to move towards the cathode part, right? So now H plus ions is going to move towards the cathode part. Now, when it moves to the cathode part, what is happening? Now, by the time when it is moving to the cathode part, the electrons, whatever it was liberated from the anode, which is moving through the external circuit, is going to come to the cathode part here. Now, at the cathode, what we are identifying? 4H plus ions I am identifying. At the same time, 4 electrons, which are coming from the external circuit. Now, both the things are mixing here. Now, here, when it mixing, so automatically it is going to form like a hydrogen content, H2. Now, whatever the H2 is coming out, this is also like a gas, whatever we have just seen like an oxygen content. Now, it is also going to come out like a bubble, and now we can able to collect it. Nothing but whatever the water content that is present inside these particular things, we are separating that into hydrogen as well as oxygen content. Right? These two things, when we send back to the engine, inside the engine, when it operates, it is going to liberate certain amount of energies and vehicle runs. And when it runs, automatically what is happening? The byproduct or the emissions, the smoke is going to like a water content, because H2O2 is, when both the things are reacting, we are going to get like water content here, right? This is one of the very, very, very important things, like a electrolysis process here. But most of the times the question is right about the hydrogen production methods. Name different methods and explain any one. If a full question appears, they are going to ask the two methods, right? So I'll repeat the things once again, please. So this is electrolysis process is going to consisting of a separate a case. Inside the case, I'm going to identify different components. One is anode, and this is an anode. This is a cathode. And now in between this, we are going to identifying a membrane. The major function of the membrane is to allow the ions in only one directions. Now these two things are immersed in electrolyte. Now these two things are connected through electrolyte only. Now these two things are connected externally by a separate wires. Right? Now, whenever it is connected to the external circuit, you are going to have the applications. Now let us start the process in the anode part. In the anode part, at the starting point, the water is going to be separated to H plus ions, electrons, as well as oxygen content, both. Now what is happening? Whenever in the anode content, this covalent bond, whatever we are going to find here, this covalent bond will be breaked. It's going to break. Whenever it breaks, it is going to form H plus, 4 H plus ions, 4 electrons, and oxygen content. Now oxygen, as it is in the gaseous form, it is going to liberate through like a bubbles out. Like a bubbles out. Right? Now, whenever it is liberating oxygen content, you can collect it out. At the same time, the electrons, whatever it is forming at the cathode part, it is going to pass through the external circuit. Now, what remains here now at the anode? Only the anions, what you can consider H plus ions. These H plus ions will move towards the cathode content through the membrane. When it reaches to the cathode part, so the electrons, whatever it is coming from the anode through the external circuit to the cathode, they are where these two things are going to mix and form like a hydrogen content. This way, you are going to produce the hydrogen content, and this can be stored, and this can be stored, and this can be utilized for your applications. Right? This is the methodology in the electrolysis process, please. Right? Let us come to the another method is the this is the second methods now. Right? Steam reforming methods. So in these particular things, you are going to produce synthesis gases now. What do you call syngas? What is the syngas? Syngas is nothing but it is a combination of hydrogen as well as carbon monoxide. Right? So most of the times what we are going to produce, this can be produced from the natural gas here. Now here in the previous electrolysis process, we were using especially uh, the water content for getting the hydrogen. Here we are going to use it something else. But most of the industries where this synthesis gas production is a very important, they are going to prefer this particular method, where they are going to have two things here. One, they are going to produce oxygen content as well as they are going to produce hydrogen content, and they are going to utilize the synthesis gas, both the things. All the things it is possible here. Now, how these people, this particular hydrogen content, they are going to produce from the synthesis syngas. What do you call syngas? So, especially whenever they need to produce it, first step is they need to separate it now. They need to separate it. What separations? CO part is there as well as hydrogen content. Both the things is mixed. Is called what you can call it as a syngas. When I need to do that, I need to separate CO as well as a hydrogen content out. Just like whatever we did in the electrolysis process. In the electrolysis process also what we did, so we are going to have a water content where we are separating hydrogen as well as oxygen content both. Now here also they are going to say that synthesis gases, whatever it is presenting now, they are going to consisting of hydrogen as well as a carbon monoxide. What we are doing, we are going to separate both the things here. Now naturally, whenever you need to separate it, it needs certain amount of high temperatures and a catalyst. You know very well, in our chemistry, you might have already studied well about these particular things. Nothing but whenever you need to have a specific reactions. In a natural process, the reaction will always be going on smoothly. Whenever you need to enhance the speed of the reactions, you are going to do two-way now. Faster reactions, whenever you need to increase the temperature, because at a higher amount of temperature means you are going to supply more amount of energies, where the bonds, the covalent bonds or ionic bonds is going to break and it is going to separate. That is the beauty of your chemistry, whatever you studied. చాలా మందికి మనకి అనిపిస్తూ ఉంటుంది, whenever you are studying it, whenever you want to separate it, why it is to be heated. మనం హీట్ చేస్తే ఎందుకు సపరేట్ అయిపోతుంది అని. హీట్ చేస్తే నీకుండేటువంటి బేసిక్ థింగ్స్, very basic things, it is going to say that the bonds, whatever it is going to form for converting that into liquid form, is separated now. Nothing but one of the biggest factor is the temperature. If I'm increasing temperature, naturally I'm going to say that my chemical reaction will be faster. In the similar process, another important factor is pressure. If pressure is more, so at the higher pressures, the reaction rate is also going to be more and faster reactions will be there. Third one is a catalyst here. So three things: one, temperature. Any reactions, any chemical reactions, please remember this. Any chemical reactions, whenever it needs to be faster, it can be done in a three different objectives, or what you can say that three different parameters it needs. One is at higher temperatures, it will react faster. Second one, at higher amount of pressure, it is going to react faster. In place of catalyst, it also going to react faster. So three things here. So now at this particular steam methane process here, the temperature will always be at higher temperatures. Nothing but it is going to have a range of 700 to 1100 temperatures. Pressure, I told you, higher amount of pressures is always needed for faster reactions. This will be at 3 bar to 25 bar pressure. That much amount of high pressures it needs. But of course, the third factor is the catalyst. Now, catalyst is going to be nickel, right? Nickel catalyst, they are going to have it. And now this nickel catalyst will enhance the speeds, enhance the chemical reactions, right? Now, let us go for seeing this particular phenomena here. So, methane gas as well as the H2O plus heat. What you can consider, this is also going to call it as the methane is a synthesis in a sun gases. One of the factor is the methane. Now, I told you one important parameter is a heating process and the pressure increasing process. These two things are going to be increased. When you increase the pressure, automatically temperature is also going to be increased. P is directly proportional to temperature, as well as Charles law is concerned here. So when methane is there, we are going to heat it, the synthesis gases. Now at the higher amount of temperatures, higher amount of pressures, in presence of the nickel catalyst, so these bonds are breaked. And now when the bonds are breaked, all the things are free. The carbon monoxide, hydrogen is going to be free. Now those two things are separated here. Right? Now, when you see that carbon monoxide content is there, when I'm considering the carbon monoxide, this carbon monoxide is not going to be stable content here. It's not stable, unstable content. You can find why it is unstable. CO2, carbon dioxide, CO2 is a stable, where carbon monoxide is an unstable content. Why it is unstable? Simple, very simple. If you remember the chemistry part, whatever you studied previously, carbon, what's an atomic number? 6. So it needs how many electrons to become stable? 4 electrons. Now oxygen content, the atomic number is 8. How many it needs? 2 electrons, right? Now when it reacts, carbon reacts with only one oxygen content, it is going to get only 2 electrons. Now it is not reaching to the neon part where it is not stable. That's why carbon monoxide is not stable at all. Whenever it is coming out, it starts searching about the oxygen content, where we are going to find the H2O, where it reacts with that and forms like a carbon dioxide and liberating the hydrogen content out. This is the process where you are going to find hydrogen is going to be coming out of that. Now what we'll do, this hydrogen content, we are going to collect it and we are going to store it in a separate methodologies here. That I'll discuss in the tomorrow sessions, what methodologies we are going to use it for the storing of the hydrogen content. This is the two methods here. One I discussed previously is the electrolysis process. Second one is the steam reforming process here, right? So these are the two methods where we are going to produce the hydrogen content here. Maybe you are going to find a lot number of methodologies for producing hydrogen, but among all these things, these two methods are going to be important methods. That's why I discussed about this, right? Now, these are the particular merits and demerits. As I told you, it is a clean energy. It is not producing any emissions at all. That's why we can use it. If I'm using, it is not going to harm the environment. That it can be done. The second major important thing is it is going to produce from the water content, which is vastly available with us. No need to purchase any water from anywhere else for producing the hydrogen content, right? And it is eco-friendly because whatever the emissions it is going to come out of this hydrogen content is water. Because of that, it is not going to create any emissions at all. So we call that as a eco-friendly part. Even what you can see, you in your car, buses, lorries, and even rockets also, they are going to use it at present as this, because hydrogen is going to be lightest element among all uh, the periodic table. Number one, so it is the lightest element. Whatever the gases we are going to use it in the rocket should have the lightest part. Then only the weight of the total rocket will be less and it moves fast. That's why this hydrogen is going to play a crucial role in the rocket technologies also. Now, if you observe the electrolysis process where we produce the hydrogen content, where it consisting of only anode, cathode, anode content, and electrolyte, where we are not going to find any moving components here. So maintenance is not going to be a very big deal. And within the short amount of, you can say that for every 1 month or 2 months, you can just add certain amount of water content. That's all. That is sufficient for you, right? Okay. Another very important problem what we are going to face it. That's what I'm going to discuss in the uh, tomorrow sessions is a maintenance or storing of the hydrogen content. Storing will be very difficult process here. That is the reason why you can see that why at present this is not used in our automobiles. So nowadays technology is going on for increasing the storing methodologies that we'll discuss it tomorrow sessions. And it what you can say that no emissions, so it what we call safest part, right? So this is the things what I'm going to discuss today. If any things if you want to discuss, let me see. In the tomorrow session, I'm going to discuss about the productions. This today's production is over. Tomorrow's storage part we're going to discuss. Please remember, this is a very, very, very important question. Hydrogen production, storage, and fuel cells. So among three, you'll get one question always. 90% of the time, question papers, external question papers consisting of this. So don't leave it. This question you